Good afternoon, respective judges. Team name is Hideout 127.0.0.1. We present to you our project RainMap India. So, what is RainMap India? So, RainMap India is a dynamic project that revolutionizes the way individuals and organizations engage with and responds to rainfall conditions across the country. By providing real-time visualizations of current precipitation patterns, the tool empowers farmers to optimize crop management, enable emergency response teams to infrastructure, aid tourist and planning travel routes, and enhance weather forecasting accuracy. The image generating aspect involves dynamically creating uh, visual representations of real-time rainfall patterns, leveraging AI techniques to generate informative maps. So the challenges we ran into the project. So the main challenge that we ran into the project is we used a collab environment which is cloud based. So it has limited CPU and GPU and limited disk space. The main problem that we ran into was disk space because the high quality satellite images were each an MB. So they and 15 images were readings were taken at an interval of 15 minutes each. So one day had almost around 90 readings. So I would explain all of this to the code. So now we'll visit to the code. So here is the code. So as you can see that a lot of time was dedicated only for making the CSV. As you can see, all of these were actually individual day CSV, which we then merged to a very big CSV. The CSV looks something like this, and it had a date time index and approximately these many features. So 3 into 256 into 256 to be exact. And then the main idea was to train a GAN. So the GAN does two things. So first, it generates images. The second important thing is that it generates images on using the temporal dependencies. For example, the clouds look in a certain way on a particular day. So it could actually predict what they would look on the very next day. So we used an encoder decoder model, a sequence to sequence model to be precise for this part. It was a very relatively simple model due to the environmental constraints. But though if given the right environment, we could create a vision advanced and modern models like vision transformers and WGANs. So we actually managed to run a few dummy tensors, though we could not actually manage to pass the whole data to the model. And we also developed a custom loss function on our own. So this is all of the code. Now I will show you our EDA part. So these are some plots that we devised for EDA. This is what the data looks like. These are some filters that we used on our GANs and CNNs. So this was the main EDA part. So as you can see, we isolated some clouds for using transfer learning. Then we used a map, and then we superimposed both of these images, get the same data. So as you can see, we can very easily spot these clouds. So if we could integrate that with our own model, we could easily predict that. But given the environmental constraints, it was not possible. So so now I will like to show about edit हो जाएगा ना. So the challenges we ran into was the the RAM was too insufficient for our process. So it was 40 GB of GPU RAM. It was all bottleneck during all of the CPU procedures. The CPU procedures were creating the data set and just reading the data set or loading the data set. And the GAN had almost 30 million parameters and a substantial size of 772 MB. It was too big for its size. So I would like to say that if we had a real environment to develop these, we could have surely did that through any possible means. Thank you very much for your time.